Hello, this is Alan again, continuing my gotcha series of videos on the ECR language. This one is really a continuation of my previous video on distributed. I wasn't really happy with what I showed you. What I showed you was okay, basically what distributed did or was and the problems of using it, but my workaround I wasn't happy with. You shouldn't really need to have to crash a work unit and force it to run on one queue. Anyway, I was thinking about this, and I think another solution that allows you the optimization of distributed, but also allows you to basically run on any number of nodes would be the following. Here I've taken my previous example, so I've got two data sets, one built on the 20 node and one built on a 40 node, and I want to use them whatever node they run, whatever they're run on, it doesn't really matter. What I've done is I've only used distributed if I know that the number of nodes this work unit's running on is equal, it's got the same number of nodes that the file was built on. So this little system for lib nodes tells you the number of nodes that this work unit's running on, and then there's in the standard library there's a get logical file attributes, and one of the attributes you can get is the number of parts. So I'll just show you that in the standard library reference. So this is the get logical file attributes, and you give it a logical file name, and one of the many attributes you can get is the number of parts that it's constructed on. So given that, I can say this has to be run on node 4. If the number of nodes that I'm running on, n nodes, is equal to the number of nodes that the file was built on, then I can just say it's distributed. Otherwise I actually have to distribute it again, and the same I can do for 40 node. Now if I run this, let's say originally on a 20 node, that means that this one here should actually just say it's distributed, but it will redistribute the 40 node one. So if I submit that, then show you the graph of what it's done. Right, so million results, so we've got the correct results there because there's a million records, so that joined correctly. And if I show you, so you can copy the work unit ID, you can then go to, let's say, ECL attributes, you can search for that work unit, and if we look at the graphs of that, graph 1, you can see that the 20 node, because it's run on the 20 node, it's known it's true, and it's bypassed the hash distribute. It's had to distribute the 40 node one, but it's got away with, so you've optimized out the redistribution of the 20 node file there. You can see that full, so that's grayed out. So let's now run that again, but this time on a 40 node 4, and let's submit that, and again it's worked. So whichever size 4 we've run successfully. And if I just show you the graph of that particular one, so we'll do the same again here, show you the graph of this one, and here you can see the 20 node one has had to be redistributed, but 40 node one, it's optimized out, and it's managed to get away without having to distribute the 40 node one. So whichever you run on, it's produced the successful results, and it's only had to just redistribute the files it's actually needed to redistribute correctly. But on both cases, whatever size 4, the work unit has run successfully and it's been run faster than it would have done otherwise. So I think this is a better solution than the one I showed you in my previous video. Anyway, all the best and see you in the next video. Cheers, bye.